Hello, my friends. In this video, we'll be exploring the autosomal DNA results, predicted phenotype traits, and even GD match results of an Iron Age Tocharian individual, an Iron Age Tocharian female from Xinjiang in China. Tocharians were an Iron Age Indo-European group of people living in Xinjiang. As you can see, this is how Chinese people sort of depicted them. You can see they look. Chinese people depicted them looking very white and very different from themselves. Um, of course, there were obviously some differences between the Chinese and the Tocharians in appearance because the Tocharians were completely different in ethnic makeup. The ethnicity of Tocharians was very different. They had some. Um, they were West Eurasian in majority of their ancestry. In terms of appearance, they probably looked more similar to such ethnicities as Tajiks or Tatars rather than like Chinese or Han. So obviously, it makes sense why the Chinese would depict them looking so white. Of course, I'm not going to say that for the majority of them they had blue eyes or blonde hair. For what I'm seeing so far, most of them were very dark. But relative to the Chinese, of course, it makes sense that the Chinese would portray them being light, because relative to the Chinese, they were obviously a lot lighter. So let's move on to the result of this Tocharian individual. Um, this is the sixth genome from this study that I'm going to cover. There is so many samples from this study. I'm going to cover the high quality genomes from this study. I'm not really going to cover the low quality ones. So you're going to see probably a lot more samples from this study. There is 200 plus samples, so you're going to see a lot more. Anyway, this is the sixth genome that I'm covering. And the mitochondrial lineage, this is a female, so she does not have Y DNA. The mitochondrial lineage for her is D5A2A1. This is the mitochondrial lineage that was predicted for her based on her the information that was found in the file. I'm not sure where this is most commonly found in. Mitochondrial lineage D descends from mitochondrial lineage HV. Very interesting. Okay, so that's quite fascinating. Let's see what she scores with my own ethnicity calculator. And with my own ethnicity calculator, she's closest to Volga, Chorny, Klubuki, Turkics. So she's quite Turkic. This is based on 393 SNPs, followed by Livonians from Estonia, followed by Malta Boy, Ancient North Eurasian, followed by Volga Aka Merians. So Iron Age Volga, followed by Livan Luchta Iron Age, which is Sami, followed by Yamna from Kalmykia, followed by Hispanics, followed by Hashferuz Bronze Age, followed by Turkic from the Caspian Steppe, and then Slavic from Himyara. So she's quite Turkic in her result. Interesting. And for the two-way mixture, she's getting modeled as a mixture of Hashferuz plus Volga Chorny Klobuki Turkic. That's the closest mixture to her. And the second closest mixture is actually Volga Chorny Klobuki Turkic plus Volga Chorny Klobuki Turkic. So it looks like she matches this reference group for Volga Chorny Klobuki Turkic quite well with my trait predictor. Let's see what she scores with Euroginske 13. Here she is closest to Tatars, followed by Afghan Turkmen, followed by Uzbek, followed by Nagai and Afghan Hazaras. So she's very Central Asian in the result. If we look at the ethnicity breakdown for the result, she's scoring 22.3% Baltic, 20% Siberian, a lot of Siberian, 18% North Atlantic, 17% West Asian, 7% South Asian, 7% East Asian, and 4% Amerindian. Then 0.8% Sub-Saharan African and 0% Oceanian. So she's scoring a lot of Siberian actually. That's quite interesting. So she's got a lot of Siberian admixture. That's a little bit interesting how she's got so much Siberian and East Asian admixture. Um, it was maybe a month or 2 months since I last made my last video on Tocharians. I touched on this topic a couple weeks ago, maybe even a month or so ago, and I sort of left this topic alone for a little bit because people weren't really watching these videos. So I don't remember what it is typical for Tocharians to score. And I am a little bit surprised now that she's scoring so much Siberian, but okay. Maybe it's typical for Tocharians to score Siberian. Well, it's interesting. Well, Tocharians are Indo-European people, so Indo-European, maybe they picked up some Siberian admixture along the way. Anyway, it's kind of interesting that she's scoring 20% Siberian and 7.5% East Asian. That's a lot of Siberian and East Asian admixture. Moving on to traits, let's move on to what she looks like. So it looks like for eye color, her predicted eye color is brown. Looks like she has a brown eye color. There's also a pretty big chance for hazel eyes for her. And there is a pretty significant chance for dark brown eyes for her. For hair color, looks like she has dark brown hair. There is also a pretty significant chance for black hair. And there is pretty much no chance for any hair color lighter than light brown. So she's quite dark. She has dark brown hair and she has brown eyes. And for skin color, looks like she has olive or Mediterranean skin tone. Pretty decisive hair, 92% likelihood for that. And for hair texture, looks like she has straight hair texture. For nose shape, looks like she is predicted to have Greek nose shape. And okay, for number of light alleles, let's see what we have here. She does not have blue eye haplotype 3. She has two light color variants here, but what's very surprising is she has two here but none here. That's very unusual. And two light color variants here. With Y-sec, she's going to score blue eyes. But because she doesn't have any light color variants here, in reality, it's the possibility of her having blue eyes is very low. Her having heterozygous genotype in this variation as well, the possibility of blue eyes is even lower. Having no light color variants in this variation, the possibility of blue eyes is even lower. If we scroll up a little bit, she has one light color variant here, so the possibility of blue eyes is once again even lower. So really, Y-sec would predict her to have blue eyes, but in reality, if you consider even the HERC2 genotypes, the reality is that blue eyes for her is completely out of the picture. Let's see what Snipper Free would predict for her. That's kind of interesting. I think Snipper Free is gonna say hazel. I think. Let's see what it's gonna say. So we see that she has GG here, and the GG in BH2. With Y-sec, it's a guarantee you're gonna score blue. But with so Snipper Free is actually saying brown as well. Yeah, Snipper Free is predicting her to have brown eyes as well. 6.7 times more likely brown than green and hazel, and more than 1 billion times more likely brown than blue. So, but with Y-sec would say she has blue eyes because Y-sec doesn't really cover this detail. It doesn't really cover in this great detail the HERC2 and OCA2 region. But yeah, she does have this genotype here in this variation, which does predispose her to having blue eyes, even though all the other genotypes in this region predispose her to having very dark eye color. Okay, she does have two light color variants in all these variations on SLC45A2, which predispose her to having lighter pigmentation of eyes, hair, and skin, which is really interesting. Two light color variants here as well. And she does not have any ginger variants in MC1R, which is quite cool. Okay, let's see what she scores for the phenotype oracle. The closest phenotypes to her are the following. So this is the closest phenotype that she scores, followed by this, followed by this. So this closest phenotype is actually exactly what I had in mind for Tocharians. This is exactly what I pictured Tocharians to look like. So I'm very pleased that she's scoring closest to this. This also sort of is what I pictured Tocharians to look like. So once again, I'm quite pleased with this showing up. This is, I guess, sort of like a French or Spanish-looking person. And with the oracle, with the two-way oracle, she's getting model closest mixture is 50% this plus 50% this. Second closest mixture is 50% this plus 50% that. And the third closest mixture is 50% this, kind of like South Asian looking person, plus 50% this. Very interesting. Beyond that, it gets a little bit further. The distance gets a little bit further. Okay. Let's see what she scores for the biomarkers panel. Looks like for the biomarkers panel, she has above average level of vitamin D, above average level of LDL cholesterol, below average level of HDL cholesterol, which is bad. Both of these results are bad. Unfortunate. She has above average glucose level, which is kind of bad. She has above average level of hemoglobin. She has above average blood pressure, which is also kind of bad. She has below average level of iron in the blood, which is good. She has a below average predisposition to sex hormone binding globulin. She has below average level of red blood cell count in blood, which is okay. She has a below average number of base pairs, so she has a predisposition to live shorter life and lesser number of telomere length. Kind of a bad predisposition to have. And for her expected height, it looks like she has a expected height that is quite quite tall, taller than average. Very interesting. Okay, let's see what she scores for the polygenic risk scores. So it looks like she has a below average odds for hemoglobin E disease. She has a below average odds for migraine, a below average odds for lupus, a below average odds for gout, a slightly below average odds for thyroid cancer, a below average odds for eczema, a high odds for exfoliation glaucoma. She has a slightly above average odds for pigmentary glaucoma. She has a slightly above average odds for primary congenital glaucoma. She has a below average odds for polycystic ovary syndrome. She has a average odds for cataracts. She has a very low odds for age-related macular degeneration. She has a average odds for rheumatoid arthritis. She has a slightly above average odds for Tourette's. She has slightly above average odds for epilepsy. She has average odds for asthma. She has slightly above average odds for leukemia. She has slightly below average odds for vitiligo. She has slightly above average odds for myopia. She has slightly below average odds for primary biliary cirrhosis. She has average odds for stroke. She has very high odds for male pattern hair loss, which is not surprising because she's a European. She has average odds for atrial fibrillation. She has slightly below average odds for deep vein thrombosis. She has slightly above average odds for unipolar depression. She has high score for bipolar type 1. She has high score for schizophrenia. She's actually she scored the highest for bipolar type 1 and schizophrenia out of all of the polygenic risk score page that she scored so far. She's scoring average for type 2 diabetes, high for type 1 diabetes. She's scoring below average for Alzheimer's, below average for multiple sclerosis, no risk variance for breast cancer, 7 risk variants out of 12 for testicular cancer, and some important variants in keto G. 2 risk variants for celiac disease out of 10, quite typical. No risk variants for GSS. 5 risk variants for Crohn's, none of them are in the important variations. No risk variants for Parkinson's. No risk variants for Gilbert syndrome. No risk variants for basal cell carcinoma. No risk variants for Treacher-Collins syndrome. No risk variants for Pfeiffer. No uncommon risk variants anywhere else. So the only thing in this result that's really quite concerning is the risk score for bipolar type 1 and the risk score for schizophrenia. And I guess the risk score for type 1 diabetes as well. So the things that we have to watch out for is bipolar type 1, schizophrenia, and type 1 diabetes. So let's explore the result a little bit more, the monogenic traits, and we're going to find out why she scored the way she did. So it looks like she has a predisposition to a warrior phenotype, which means quicker dopamine reuptake, low dopamine levels, and high stress resilience. Definitely some predisposition to that. She's got GG and Combs-Valmet variation. Some other genotypes in COMT, also like this one, for example, she also has warrior genotype in this variation of COMT as well. She has TT in this variation of COMT, which is also a fairly rare genotype that increases the risk of schizophrenia. So she has all these genotypes in COMT and MAOA and MAOB that predispose her to being a warrior, essentially. For the DRD2 gene, actually, that's kind of surprising that despite scoring so high for bipolar and schizophrenia, she actually has a predisposition to intermediate or lesser number of dopamine D2 receptor sites in the brain. That's kind of interesting. So she has heterozygous genotype for the no-go learner variation. She has this genotype which leads to less dopamine D2 receptor sites and decreased risk of schizophrenia. She's got a gene TAC1. I don't really remember exactly if that contributes to the score for schizophrenia or not. I don't remember that well. It was a couple months when I was coding this logic, so I don't remember whether or not that contributes to the risk score. So I can't really tell you that right now. Uh, okay, she's got AG in this variation of DRD2, which has implicated a slightly higher number of and slightly increased likelihood of schizophrenia. Okay, so that contributed to the score, and I remember that this does contribute to the score, so that did contribute to her scoring high for schizophrenia. She has AC in this variation of DRD2, which I don't think that contributes to the score, and this implicated in a slightly higher likelihood of alcoholism. Definitely quite interesting. But what caused her to score so high for schizophrenia and bipolar? She has this genotype which is associated with bipolar disorder. That does contribute to the score for sure. What else though? There's some genotypes that aren't shown on the screen that contribute to the result, which also um, which also contribute to the score. She's got this genotype which leads to somewhat lower odds of bipolar than schizophrenia, but this does not play a role in the polygenic risk scores. She's got this genotype in T rank 1, which leads to below average odds of bipolar and schizophrenia, but it does contribute to the score. Um, she's got this genotype which offers some protection from schizophrenia, but this does not play a role in the polygenic risk scores for schizophrenia. She's got this genotype in DRD2, which leads to higher odds of schizophrenia. This does play a role in the polygenic risk scores. Um, okay, interesting. Interesting. So for 5-HT and serotonin panel, looks like she has a predisposition to lower levels of 5-HT and serotonin. So she does not have long form 5-HT TLPR. We know that for a fact because if she had long form 5-HT TLPR, she'd be scoring higher levels of 5-HT and serotonin, and she doesn't score that. She has a predisposition to being a heavier drinker if she was an alcoholic. She's scoring low for gout. We remember. Actually, was she scoring low for gout? Let's check that again. Oh, she was scoring slightly above average for gout. So she's scoring slightly above average for the risk of gout. And yeah, so she's scoring slightly above average for gout. She's scoring, I think, slightly below average for lupus. For autism, she has a slight predisposition to higher risk of autism. Quite interesting. For lactose persistence, she does not carry the European lactose persistence mutation. She's not even a European, so you can't expect her to carry the European lactose persistence mutation. For OXTR and empathy gene, she has a predisposition to higher level of empathy. Um, taking into account these 5 variations right here, she has a predisposition to higher level of empathy. For diabetes, looks like based on well, we remember she was scoring high for type 1 diabetes. Let's see what for HLA gene, based on her genotype here, she has heterozygous genotype, which leads to intermediate odds for type 1 diabetes. So she does have the risk variant here for increased odds for type 1 diabetes. I'm going to be very interested to see her score for the HLA gene panel. For hemochromatosis, no risk variance for hemochromatosis. Alzheimer's, no risk variance in the APOE. For multiple sclerosis, no risk variance for multiple sclerosis in the HLA gene, which is really good. So we probably will see really good results for the HLA gene panel. Cardiovascular issues, lower odds of cardiovascular issues. So she has a predisposition to lower odds of cardiovascular issues as well. We will probably see really good results on the HLA gene panel, as what I'm predicting right now. Okay. Myopia panel looks like well, she was scoring above average for myopia, I think. Hold on. Let's see. Myopia. Yeah, she was scoring above average for myopia. So let's see the myopia panel again. She does not have the G allele here, which would protect from myopia, and she has these genotypes, which also increase the risk of myopia. So because of that, she's scoring higher for myopia. For facial morphology panel, looks like she has European genotype in all the EDAR variations, all the European genotypes in EDAR. She has a genotype for slightly shorter midface length. She has a genotype for intermediate odds of protruding nasal bridge, larger nose size, and lower odds of missing teeth. She has a genotype. She does not have any predisposition to vitiligo whatsoever. She actually carries the micropenis mutation for miscellaneous section. Very, very interesting. So this is once again another case of miscalls. I notice this quite frequently. I noticed that these samples that I analyze from academic studies carry the micropenis mutation. I think this is a problem with the method they use to genotype them. So I don't think they actually do carry the micropenis mutation. I think this is just a common problem with the chip. So once again, I don't think this is genuine. Just ignore that. Better performing muscles, likely sprinter rather than endurance athlete. One fat gene variant in FTOs, RS99, 39609, high odds of obesity and sleep apnea. She does not have the variants for increased pain sensitivity in SCN9A. And okay, she has normal or faster metabolism of caffeine. Okay, for alcoholism panel, her risk of alcoholism is essentially average, spot on average. For MTHFR panel, looks like she has this very unhealthy genotype, which leads to a couple of risks associated with impaired folate metabolism. For leukemia panel, she has a genotype that corresponds to higher odds of leukemia. Okay, for celiac disease, she has some variants for celiac disease in CCR3, but the most important variations for the risk score for celiac disease are in the HLA gene, and she does not have any risk variants there. For male pattern hair loss panel, she actually does have some risk variants in the AR gene. For example, this one right here, which leads to high odds of baldness. Most people who are not sub-Saharan African descent have the same genotype here, which leads to higher odds of baldness. She has all these genotypes, which leads to higher odds of male pattern baldness, so she is predisposed to male pattern hair loss. If she has a son, her son will probably be predisposed to male pattern hair loss. Okay. Canavan syndrome panel, no risk variants for that. HIV and AIDS panel, she has one protective variant in this variation, which leads to a 60% reduction in HIV viral load. And for HLA gene panel, looks like she has a predisposition to lower odds of autoimmune disease, which is really good to see. So she has some protection from autoimmune disease. For MTRR gene panel, looks like she has one risk variant for disorders of intracellular collagen metabolism, quite good. For CBS panel, and homocystinuria panel, looks like she has a predisposition to actually elevated homocysteine levels, which is really bad, and that leads to increased odds for various heart issues and things like aneurysms, stuff like that. So that's quite unhealthy. That's quite unhealthy to score. Thyroid cancer, she's scoring some genotypes for lower risk for thyroid cancer. Let's see what she scores for that actually, for thyroid cancer. I think it was below average. No, it's just average. It's spot on average. Okay. For muscular dystrophy myopathy, no risk variants for that. For color blindness panel, she has one risk variant for color blindness, NOP, and one SW. For FTO gene panel, she has heterozygous genotype in all the FTO variants, so she's pretty much heterozygous for all the fat gene variants. Although she does have all the other genes that are implicated in obesity, she has genotypes that are protective from obesity. So she's all in all, she's quite protected from obesity. For syncope, based on one SNP, she has spot on average risk for syncope. For biotraits panel, looks like she has some predisposition to type 2 diabetes, some protection from predisposition to anger. She has 2 copies of the farmer CLT-CL1 gene variant, which leads to a selective advantage in processing carbohydrate-rich diets, presumably including those with lots of sugar. And for vitamins and levels, she has higher levels of vitamin K, lower levels of vitamin E, and she's predisposed to lower levels of vitamin A or retinol. She also is predisposed to higher levels of vitamin B6, lower levels of vitamin B12, and she has a genotype which leads to decreased protection of neurons against glutamate toxicity and decreased rate of glutamate degradation. For blood group panel, let's move on to the final topic of the video. Looks like her predicted blood type is actually type B. Looks like her blood type is most likely type B. Type AB is also quite possible, but it is most likely type B. Um, Type A is improbable. Type O is quite impossible. So most likely her blood type is type B. I'm seeing most common blood type is type O. So mostly I'm seeing blood type O in the results. Usually when I analyze a sample, I'm seeing type O in the results. So I'm always quite thrilled to see a result that's anything other than type O. Uh, but this is the result with blood type B. Well, thanks for watching until the very end. Leave a like if you enjoyed the video, and um, of course, you can download the file that I've been analyzing in this video, the Tocharian sample that I've been exploring today, from link which is in the description of the video, and you can buy the tool that I'm using to generate these health and traits reports from my itch page, which will be in the description of the video as well. I will be uploading the version 13. By the way, you can check right here on the information page. You can check the version that was used to generate this report. So if you check the version right here, it says version 13. That's because I'm using version 13 to generate this report right here. And version 13, I'm actually gonna upload that on May 22nd onto the itch page. And when I upload that version there, I'm gonna keep making. I'm making little changes every day. I'm making little additions. I'm adding stuff, making it slightly different. There's little changes that I make every single day, adding things, adding little diseases or traits, SNPs, stuff like that. Maybe changing things, changing words that I've used before, making things more easy to understand. But on May 22nd, I will add version 13 to the itch page, and you will see that it will be publicly accessible. And I will also change the price. The price will go from $13, which is the current price right now, and it's going to be maybe 24, maybe 23, I don't know, maybe 25. It's going to be a different price. And it is an executable. So the price being in 20s makes sense because you buy it once and you get to run an infinite number of files, right? So it's not like you're purchasing one report. You're purchasing a tool that you can use an infinite number of times. So it makes sense for it to be quite expensive. Anyway, thanks for watching until the very end. Leave a like and subscribe, and thanks for watching. Goodbye.